Hello everyone, my name is Ajinkya Nistane from class A6 and today I am going to explain some very important mathematical concepts that are widely used in quantum physics. The topics include inner product, norm of vector, distance function, tensor product, assembling system. The, these are the foundational ideas that appear not in just a theoretical concept, also in real world simulations and quantum computing. Let's begin. Before we dive into the details, let me briefly introduce what we're going to cover. We'll start with the inner product, which helps us to measure angles between the vectors. Then we will move to the norm, which tells us the function of a vector. From there, we will discuss the distance function, which helps us to measure how far apart two points or vector are. Then we'll then explore the tensor product, which are important in quantum states combinations. And finally, we'll look at assembling system, a concept that comes into play when solving complex equations numerically, like in simulation. Let's start with the first concept, the inner product, also called as the dot product, in a way of multiplying two vectors to get a single number a scalar. It is calculated as the sum of the product of corresponding components. For inner product, the formula is for vector A and B is A dot B. We can write as A dot B, which is equal to mod of A into mod of B into cos theta, where cos theta is the angle between two vectors. For example, we have 1 comma 2 and 3 comma 4, which is also we can write in I cap j cap. The here the inner product is 13 plus 20, 3 plus 8 is equal to 11. 3 1 the 3 plus 4 to the 8, which is equals to 11. It is also a geometric meaning. It tells us how aligned two vectors are. If the inner product is 0, the vectors are perpendicular or orthogonal. In physics, especially quantum mechanics, the inner product is used to check the probability of a state transition or the test orthogonality between quantum states. Next, we have the norm of a vector. The norm is essentially the length or a magnitude of the vector. You can think of it as a distance from the origin to the point represented by the vector. The most common is the Euclidean norm, also called the L2 norm, which is just the square root of the sum of the squares of the components. Euclidean form is double mod of V, which have the formula square root of v1 square plus v2 square till v1 square. For example, we have 3 comma 4, which gives the square root of 3 square plus 4 square. Now in under root we have 3 square, which is equal to 9 plus 4 square is equal to 16. In under root we have 9 plus 6, which is 25, and root 25 is and 5. So we have right here answer 5. The idea of vector length is very important when we want to normalize vector and compare the sizes. Norms are used to measure vector sizes in various applications, which is lead to us to our next topic, which is distance formula. A distance formula, distance function. Distance function tell us how far apart two vectors are or a point are in a space. The most commonly used one is the Euclidean distance, which is similar to the norm just applied to the difference between two vectors, which we have learned in previous slide. Euclidean distance have formula d in a comma b, which is equal to square root of a1 minus b1 whole square plus a2 minus b2 whole square till n. It is widely used in physics in and ML and geometry. For instance, the distance between the point 1 comma 2 and 4 comma 6 is 4 minus 1 whole square plus 6 minus 2 whole square, which is equal to 9 plus 16, which is equal to root 25, and which is equal to 5, where we have to measure how similar or different two vectors or data points are. Now let's talk about tensor product. These are used to combine vectors or matrices to form a higher dimensional spaces. In quantum physics, they are particularly important because they let us describe the state of combined system. For vectors u and v, we have u into cross v form a matrix. For example, if you have two vectors a comma b and c comma d, their tensor product gives us matrix like AC, AD, BD, and BC. They are particularly important because they let us describe the state of combined system. This is especially useful when describing two particles in quantum computing, each with their own state, and combining them into a single system state. Moving on to the assembly system, this refers to the process of combining multiple smaller systems or equation into a larger global system. In numerical simulations, like those using the finite element method, we model each small part of element of a physical system and then assemble all the parts together into a global matrix or a system of equations. This is crucial in simulations of a structure, heat transfer, fluid flow, and also in quantum simulations where the entire system behavior emerges from the interaction of its smaller parts. All these concepts are interconnected between them. The inner product helps define norm, and norms are used to compute distance. Tensor product allow us to expand our vectors, spaces, and model complex system. And when we assemble system, we're often putting together components that involve all the mathematical tools and inner product norms tensor to form a solvable model. So understanding the foundational tools help us understanding and build more complex physical models. These ideas aren't just theoretical, they are applied in real world areas. So in quantum physics, we use tensor product to represent combined quantum state. In machine learning, we use norms and distance function to compare data. In physics simulation, assembly system is necessary for solving large sets of equation, and in data science, the inner product is used as dimensionality reduction techniques like PCA. The concept power technologies all around us. So in conclusion, to summarize, we have explored the first inner product, which measures similarities and angles. In second, we have covered the norm, which gives us vector magnitude. Then the distance function, which helps to compare a distance or how apart a vectors are. Then we have discussed the tensor product for combining systems and assembling system for solving large problems. All these are the core tools in mathematics and physics and are essential for understanding complex systems, especially in quantum physics. So thank you very much for your time and attention. I hope this presentation helped you understanding these important topics. I will be happy to answer any questions if you have. Thanks.